Hi, good evening dear students. Welcome to physics online class. In previous class we learned about the definition of a photon and its properties, and also learned about matter waves or deBroglie waves and deBroglie wavelength or matter waves wavelength. In today's session, we are discussing about derivation of a deBroglie wavelength. Derivation or expression for deBroglie wavelength. Heading: expression for deBroglie wavelength. Derive an expression. Derive an expression. Derive an expression for deBroglie. Derive an expression for deBroglie wavelength. Okay, this one is the 3 marks of derivation. Derive an expression for deBroglie wavelength, or derive lambda is equal to h divided by p or h divided by mv. H divided by mv. Dear students, already know the energy of photon equation. The energy of a photon is, first step, the energy of a photon is E is equal to h nu. We know the equation, that is the E is equal to h nu, we call as photon energy. This is considering equation number 1. Okay, I am going to consider, this is the equation number 1. We know E means energy, h Planck's constant, nu frequency. Then if a photon is regarded as a particle of mass m, then its energy is converted into in terms of mass by considering theory of relativity equation. Using Einstein theory of relativity, using equation E is equal to mc square. E is equal to mc square we call as Einstein theory of relativity equation. Energy converted into mass and mass converted into energy. Energy converted into mass and mass also converted into energy. Okay, this one is equation number 2. ಐನ್ಸ್ಟೈನ್ನ ಸಾಪೇಕ್ಷ ಸಿದ್ಧಾಂತ ಇಕ್ವೇಷನ್ ಅನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ. ಅದು ಏನಪ್ಪ ಅಂದ್ರೆ E is equal to mc square. E nothing but energy, m mass, and c it is a velocity of light or speed of light. Now from equation 1 and 2, from equation 1 and 2, from equation 1 and 2, E is equal to E. E is equal to E. E andre enide? From equation number 1, h nu. In the place of E, mc square. mc square. mc square. Then h, in the place of nu, we are consider c divided by lambda. In the place of nu, we are taking c divided by lambda is equal to mc square. Then c get cancel, remaining h divided by lambda is equal to mc. Okay, we want to calculate deBroglie wavelength, that is lambda is equal to h divided by mc. Okay, or lambda is equal to h divided by mv. Here that is mc is equal to p or mv is equal to p. C and v are same. Then therefore lambda is equal to h divided by p, because p is equal to m into v, mass into velocity. Momentum is equal to mass into velocity. Lambda is equal to h divided by p, or lambda is equal to h divided by m into c or m into v. Okay, this one equation we call as deBroglie wavelength equation, where p we call as momentum. Okay, lambda we call as deBroglie wavelength. Okay, h we call as Planck's constant. Okay, this one is the main derivation of a deBroglie wavelength. Once again I explain this one, repeat this one. Derive an expression for the deBroglie wavelength, or derive lambda is equal to h divided by p or h divided by mp. First we have to consider equation. The energy of a photon is E is equal to h nu. Using Einstein theory of relativity equation, E is equal to mc square. From equation 1 and 2, E is equal to E. Then in the place of E, I am considering h nu, and in the place of E, mc square. Okay, here h is equal to c divided by lambda and mc square. Here how to consider in the place of lambda? C divided by lambda means we know the relation c is equal to nu lambda. Then in the place of nu, c divided by lambda. Okay, c is equal to f lambda or nu lambda. Then lambda is equal to c divided by lambda. Nu is equal to c divided by lambda. C is equal to nu divided by lambda. Nu is equal to c divided by lambda. Then c get cancelled, remaining h divided by lambda is equal to mc. Lambda is equal to, okay, this one is a lambda is equal to h divided by mc or h divided by mv. And here c and v, that two are same. Lambda is equal to h divided by p, because p is equal to mass into velocity. Okay, this one equation we call as deBroglie wavelength. Okay, next one derivation. Obtain the expression for deBroglie wavelength in terms of accelerating potential. Derive the expression for expression for deBroglie wavelength in terms of accelerating potential, or derive lambda is equal to 1.227 divided by root of v nanometer. How to derive this equation? Okay, this one also very important for 5 marks or 3 marks. First we have to consider the equation kinetic energy equation. Kinetic energy gained by the electron. ಮೊಟ್ಟ ಮೊದಲು ನಾವು ಏನು ತೊಗೊಂತೀವಿ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಕ್ವೇಶನ್ ತೊಗೊಂತೀವಿ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಗೇನ್ಡ್ ಬೈ ಎಲೆಕ್ಟ್ರಾನ್. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ gained by the electron is equation, kinetic energy equation. Kinetic energy is equal to half m square, already know. Kinetic energy is equal to half m into v square, already ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ. Kinetic energy gained by the electron is equation half m v square, equation number 1. Now multiply and divided to the m RHS side. Multiply and divided by m. Multiply and divided by m. Which side? RHS side or both side. RHS. Now kinetic energy is equal to m v square divided by 2 into m divided by m. Multiply and divided by m. Here in LHS side m divided by m get cancelled. Therefore kinetic energy is equal to m into m square v square divided by 2m. But already we know that, but p is equal to what? M into v. Then p square nothing but here m square v square. Substitute m in the place of m square v square, that is p square. Now kinetic energy is equal to p square divided by 2m. Okay, this one is the equation number 2. Equation number 2. Then already know work done by the electron. Work done by the electron is W is equal to kinetic energy is equal to EV. Equation number 3. From equation 2 and 3, from equation 2 and 3, from equation to RHS side, p square divided by 2m is equal to E into V. Then p square is equal to 2m into EV. Okay, this LHS 2m, when you shift RHS side, it becomes into. Then p is equal to what? Root of 2m EV. Okay, this one is a equation number 4. Equation number 4. Next, using deBroglie wavelength expression, using deBroglie equation, lambda is equal to h divided by p. Lambda is equal to h divided by p means substitute this one equation. P in the place of p, substitute this one. Okay, consider this one. Root of 2m ev, equation number 4. Root of 2m ev, because from equation 4. Now on substituting h is equal to its value, Planck's constant value 6.63 into 10 to the power of minus 34 joule second. Mass of electron, that is 9.1 into 10 to the power of minus 31 kg. Electron charge 1.6 into 10 to the power of minus 19 coulomb. Substituting these value in above equation, finally we get lambda is equal to 1.227 divided by root of v nanometer. Okay, this is the final expression of the deBroglie wavelength in terms of accelerating potential. Okay, this one is a very important for problematic and CET NEET also. Okay, up to here 2 derivations are over. Next one, 2 more important question. Write the expression for deBroglie wavelength of a particle in terms of kinetic energy, and explain the terms. Number 1, equation. Here its expression, this one is important for 2 marks. Lambda is equal to h divided by root of 2m kinetic energy. Lambda is equal to h divided by root of 2m kinetic energy. H we call as Planck's constant, and kinetic energy is kinetic energy of a particle. Lambda we call as deBroglie wavelength. Okay, this one is very important for 2 marks. Okay, this equation we call as deBroglie wavelength in terms of kinetic energy. Lambda is equal to h divided by under root of 2mk or kinetic energy. Okay, up to here 2 derivations are over. Thank you.